Hey YouTube, what's going on? You're on a pick of the week with Daniel Dallas. We are going to go through one interesting problem related to circles and angles. I picked up intentionally for you guys. Can you solve that? It's right on to know. Okay, so you're given a circle with a center O1. And here is another circle that goes through center O1 and has another center which is O2, as shown on the diagram. You are also given that there is triangle LMN and it's arranged by line segments. And all 3 points L, N, and K, they are on a straight line segment KL. Okay, so what do you need to know? What do you need to find here? You need to find what's the measure in degrees for the angle LNM. LNM. Okay, so if you're ready, try to do it by your own, and I'm starting explaining right now. So the target angle that you need to define is the angle, say x in degrees, and this is the angle that you need to define, okay, this angle here, between two line segments LN and NM. The clue to that problem is that two circles actually have the same radius. And indeed, if you connect O1 and O2 with straight line, you understand that that is going to be the radius for the first as well as for the second circle. So that's why this is the radius. So if you like, you can mark as R. So this is the radius. But still the problem is not like very obvious how to approach to the angle x, because you're not given any data. So there should be some hint for you guys that if it's arranged, so if this angle within a triangle, and also you're given circles, so obviously you need to find some inscribed angle or the central angle that you know. And obviously the measure of angles should be like pretty, that's pretty common for equilateral triangle, for example, or a specific triangle like 30 and 60 degrees. You understand what I mean, okay? So that's why, what are we gonna do? Let's try to connect all 3 points O2, O1, and M with straight line segments. And as you notice, because that's the radius, and this also the radius for the second circle, and this is the radius for the first circle, you have angles by 60 degrees everywhere. So triangle, so you can fix the fact that triangle O1, O2, and M equilateral. It means that each angle 60 degrees. Okay, so for example, that angle 60 here is, and here is 60 degrees. But still, it's not obvious how to approach to the angle L and M. What I recommend to do, I would like to recommend considering angle M and K. So angle M and K. M and K. So this small angle is actually inscribed, and those points M and K are supporting points. They support the arms of that angle. So that's why this definitely inscribed angle. Inscribed angle. So that's why ideally if you find another inscribed angle, let's arrange another part of the triangle that we considered before. Obviously, this triangle is the same with the same radius, radii, okay? And that means triangle O1, O2, and K actually is an equivalent to the triangle O1, O2, and M. And it means it also equilateral with 60 degrees angle. So what you can do, so you know that this angle is 60, So this angle is 60. And that's why in total, angle M01K, so let's consider angle M01K, it will be equivalent, or it will have the measure 120, right? And it's also supports or based on 2 points, MK, or on the arc length MK, the major arc. So this is the major arc here, okay? So that's why, because two angles, MO1K and angle MNK, they both have MK points. That means they are the same. They're both inscribed and they are the same. So that's why angle MNK will have the measure of 120 degrees. So that's why we can mark that the angle inside there, oops, not good color, let's take that one. So this angle is the angle with 120 degrees. So that's why angle X is just simply adjacent. So angle X plus 120 will give you 180. From where angle X is 60 degrees. That's how it can be solved, and actually it was based on the fact that we were looking for inscribed angles. There is no other way to solve that because there is no reference, there is no like given data, no any angle is given to you. So that's why you need to find like good triangle, like equilateral or well-known triangle, like with 30 and 60 degrees, you know, and that's the solution. So hope you like that. That was pretty tricky, it seems to me. It can be referred to definitely higher GCSE, like outstanding or challenging maths, or even to A-level or IB stuff. Thank you guys for watching, and peace out.